So this is a video to explain one of the subnetting problems that I had a question on. And the problem was we needed to take a Class B address and figure out how many subnets we needed in the topology, and then how many hosts we would need on each subnet. And it was a classful subnetting, so we really only have to cut the subnet up one time. If this was a VLSM, we would always take the largest group of hosts, find out a network for that, and then take the remaining pieces and further subnet on the remaining pieces. But in this particular case, we had 4 subnets, and taking into account for the 25% growth, that means we need to have one extra subnet in the picture. And if I can get my So that gives us a total of 5 subnets. The different groups are listed here, taking in the 25% growth and then rounding up to the next integer, we get this group of addresses. Now, we don't worry about the serial connection because the serial connection is a point-to-point, so you don't have to worry about increasing that. That's going to be 2 no matter what. But we have a host number of 232. So we analyze that in the powers of 2 to kind of find out how many zeros that we need. And if you go down, you'll notice that 232 is bigger than 128, less than 256. So that means we're going to need 7 wouldn't be enough. We're going to need 8 zeros in our subnet. Well, if you have a Class B, you have 16 bits to play with, 16 zeros. But we only need 8. So we have 8 zeros, and out of those remaining 16, they become 1s. So it's sort of like dividing up a pizza. We have this Class B pizza. We have to slice it up. And you always make the first slice based on the biggest number of hosts, that you need. In this case, 232. So what that means is with 8 zeros is if you have 8 zeros, that means you're going to have 24 1s. So that gives us a subnet mask of 255, 255, 255. So for example, if we were doing marketing was 63. So if we were to go down and find 63, a number, 32 is too small, 64 is too big. So we might think, oh, you need 6 zeros. But 63, yes, it's smaller than 64, but you remember, this powers of 2 tells you how many addresses you have. So I have 64 addresses, but I really only have 62 that I can assign to hosts, because the first address in any subnet is the network name. The last address in any subnet is the broadcast address. So 64 wouldn't really work. You actually have to go up to 128 and use 7 zeros. So figuring out how many zeros is one thing, but we have to figure out what our addresses are going to go up by. And this is where that subnet chart that I showed you earlier kind of helps out. whenever you're doing a host problem, you always start on this far corner. And I'm going to need 8 zeros. So I count 8 zeros from here. Well, if all of these are zeros, because that's 8, that means that my subnet mask, is the next number. So to go back to if we were doing marketings and we said we needed to borrow 7 zeros, or not borrow 7 zeros, have 7 zeros, then we would borrow, the rest would be ones from the 16 that are available to us on a Class B. That would put me at 26/26. So if all of these are zeros, that means my subnet mask would be a /25, because that would give me 1, 2, 3, 4, 5, 6 zeros, or 7 zeros, I'm sorry. I said 6, 7 zeros, which is what we would need. So in that particular case, when you use this chart, the fact that I have a /24 tells me two things. It tells me that my networks are going to go up by 1, and it tells me that I'm going to be doing this in the 3rd octet. And it also, by the way, tells me what my subnet mask would be. My subnet mask would be a /25, 255. And it would be in the 3rd octet. So what that gives me are these 4 subnets down here. I come home with 172.16.0.0, and they go up by 1s in the 3rd octet. So this would be the one that I would use for sales. This would be the one I use for marketing. This would be the one I use for the 3rd network, which I can't remember the name. And then the last one, even though, would be for my serial connection. But you see, the problem here is every one of these pieces of the pizza that I sliced up is big enough to feed 232 people. Actually 254, but we only need 232. So I'm wasting a lot of addresses here. So the next step here would be to do VLSM and take each one of those other subnets and further cut them down, the other slices, until we have slices that are just big enough to feed what we need. So that's the way I would attack this problem, and it's a classful one, so that's why we have all the sizes the same. A VLSM one, we would continue on and have more things to do.